So the next time we see each other, what you need to read is 4.9. 4.9 is going to have 5 new points to the quizzes, maybe none of which are new to your life. For some reason, after they've already done a few proofs, in 4.9 they tell you how to write proofs, and we already wrote a proof for 2 so far. So 4.9, when you read it, it's not necessarily new news to your life, because I've said some of these things to you the day that we did the proof of the supplement theorem. But it is new to the reading, it is new to the quiz. So there's 5 new points from 4.9 coming at you that's related to how you're writing proofs. The rest of the quiz almost is an instant replay of today's, so you can basically just use yesterday's study paper to get ready again. There's nothing new. If you got them right today, just cruise on that. The only adjustment you're going to have to make is the new words. So today you were filling in 2 new words. What were the words of the day today?
Hypothesis.
There was a thing called the hypothesis, and there's a thing called the conclusion. Tomorrow, this will be a 6-point question. How could I turn hypothesis and conclusion, there's 2 points, how could I turn that into a 6-point question? Yeah, like what goes with those words? Okay, who's who?
If is hypothesis.
The hypothesis is the if part of a sentence. The conclusion is the then part of a sentence. That's true. How else could we explain the difference between those words?
Define it.
Maybe. Anybody have thought specifically? Has to do with proofs.
Is it statements and reasons?
It has to do with that-ish.
Definition of statements.
We'll come back to that one. But that's going to be a 6-point question. There's 4 of the 6. We shall return. Somebody give me an if-then sentence that we've had.
If A equals B,
What?
then B equals A.
Okay. If I give you that sentence and ask you for what is the hypothesis, somebody tell me what is the hypothesis of that sentence?
A equals B.
A equals B. This is the hypothesis. The word if is not part of the hypothesis, but the word if lets you find the hypothesis. That is the hypothesis of that sentence. What's the conclusion of that sentence then?
The B equals A.
The B equals A. That is the conclusion of that sentence. Question about that concept? They'll do some of that in the homework. Somebody tell me Theorem 4.4. What's Theorem 4.4 say? Right angles are congruent. Can somebody restructure that in what I think is a worse way? That's why we memorize it the way we memorized it. But can somebody make that sentence an if-then sentence and still have the same capture of the same truth?
Make if.
Go, Nicole.
If 2 angles are right angles, then they're congruent.
Okay, so we could say if 2 angles are right angles, then they are congruent. That's the same truth, it's just a longer sentence. What's the hypothesis of this one?
The 2 angles are
2 angles are right angles is the hypothesis. If they are congruent, that's the conclusion. That's what the kind of thing you're going to do tonight, and what's the easiest homework you've had in geometry in quite some time. Okay, so we're going to go page 109 for homework, number 1 and number 2. Number 1 is like this, identifying hypothesis and conclusion. Don't include the word if in your answer. Don't include the word then in your answer, but use the if and the then to mark them. If they want to get fancy, instead of starting with if, they'll put the if at the end of the sentence. Just make sure you're just careful about that. Wherever you find the if, whether that's at the beginning or end of the sentence, the if is the hypothesis, the then is the conclusion. Number 2 is more like this second thing we did. they'll give you a sentence that isn't an if-then sentence, and they want you to reshuffle it so it's if-then, an if-then sentence. So page 109, 1-2 is like what we already just did on the board. And then flip the page onto 110. 110, there's a 1 to 6. It's pretty much all words coming right off your quizzes, either old words or new words. But the 1 to 6 is just definitions, properties, theorems, words that you should know. If you don't know them, find them, they're around. But that should also be a pretty easy homework page relative to what the geometry homework usually looks like. So 109, 110, homework. 4-9 read. 4-9 is the end of the reading for the chapter, and then we'll just try to get better at what we're doing here. I just need to tell you what the other 2 points of that are in just a second. Question about what you're doing for tomorrow? Yeah.
Is it just 1 or
1 and 2, and then flip the page. There's a 1 to 6 of like old words. See them?
2? Yeah.
Okay. So 109 spills into 110. So a 1 and 2, and then a 1 to 6. That's still that's a pretty easy number for us. Question there? Yeah.
You said the video with the proofs is 4-6.
4-6 is the, yeah. Anybody who's stumbling on the 103 homework, if you're stumbling over the proof of the complement theorem, you need to check the 4-6 video and watch the proof of the supplement theorem, and it'll tell you which words to switch and exactly how to switch it. I'm going to do one proof today. I almost did a proof yesterday, but we ran out of time and I just didn't do it. So we were going to prove the vertical angle theorem. So first, somebody tell me, what is the vertical angle theorem? So vertical angles are congruent. And then I'm going to say a bunch of stuff that you're probably going to read tonight when you read about proofs. So you're going to read about probably everything I'm going to say in the next 5 minutes. It's probably a preview of the reading, so when you read tonight, you're like, he just said a lot of stuff. Yeah, that's all true. If we're going to do a proof, somebody remind us, what's the first thing that we do to get ourselves a proof going?
Take the 2.
Even before that. Anybody a theory on how we're going to start every proof we'll ever start?
Don't you write the thing out?
Well, I've got the sentence, but yeah, what do you mean, write what thing out?
I was talking about that, but then don't you put like a little T-graphs?
I'm going to get to that. Yeah, we're going to make a little like P-graph looking thing, but not immediately. There's something else that always comes from it.
Are you supposed to draw it?
Supposed to draw a picture. Okay, so if we're going to draw a picture of vertical angle theorem stuff, what's a picture of vertical angles look like?
Make an X.
Make an X. And then we want to give things names so it's easier to talk about these things later. So maybe I need a dot here and I could call that A or B or C or D or E, something like that. It's not even a bad idea sometimes to put, I'll do this first. If I want the name of this angle, what's the name of this angle in this corner? Angle ACB. This is angle DCE. This is angle BCE. That's angle ACB. If I don't want to use those 3-letter names, it's my drawing, right? I can do whatever I want. I could go like 1, 2, 3, 4. And now instead of calling this angle ACD, I could just call that angle 1. It's easier. Do what you want. It's your picture. Doesn't matter to me. But we always start off with a picture. Every proof starts with a picture that represents what we're talking about. What else happens up front? It's a magic word that starts with G. There's always something that you're given. It's from the sentence. What are we given? Why did I draw what I drew? What did we know about it? Vertical angles. Who would be an example of vertical angles? Angle 1 and angle 3 are an example of vertical angles. If somebody else picked what pair, they'd be just as good. Nicole said 1 and 3, what could somebody else say? 2 and 4, just as good, doesn't matter. You just need to pick a pair. Then there's another magic word. Starts with a P. Proof. There's something we're trying to prove. Because these are vertical angles, something just like happens. What happens because 1 and 3 are vertical angles? What's true about them? They're congruent. Okay, so that's how every proof has to start. You need a picture that represents the story, figure out what you're given, figure out what you're trying to prove, and then we're going to build this big thing. I don't have this pre-numbered. You never know how many steps it's going to take. You just start going in there and see what happens. So let's take a step back over here. I just used some words that were in the reading. Can anybody tell me the hypothesis, the if part, what that has to do with proofs?
Is that what you're given?
It is what you're given. The if part is always what you're given. The then part is always what you're trying to prove. So there's our 6 points for tomorrow. Hypothesis is an if in a sentence. The hypothesis is the given when it's proof time. The conclusion is the then in a sentence. The conclusion is what you're proving when it's proof time. Question about the 6-word thing. Question about what we've got here. Reason 1 is all well, I should head these off. What was this heading? This is for statements. This is for reasons. There's 4 main types of reasons you've seen a lot of. What are some main types of reasons?
Definitions. Properties. Postulates. Theorems.
Theorems, all true. Then there's a 5th reason that we generally will start every proof with. Given. We're always going to write given, almost always write given, and just write down what we're given. Angle 1, angle 3 are vertical angles. And then you scan your memory banks. On the quiz, I think you did something, well, let's spot a reason first. What's your most common reason you'd use? Type of reason. Definitions, theorems, postulates, properties. Definitions is usually the champ, and this is not an exception. What's the only definition we could use to really do anything with this? Definition of vertical angles. So on your quiz, what did the definition of vertical angles have to do with?
They're always congruent.
But that's what we're proving. Okay, so we can't prove the vertical angle theorem
definition.
by using the vertical angle theorem. That's a common beginner mistake. It would be like if I wanted to prove that, prove to my parents that I should be allowed to go out at night. You can't convince your parents by saying, I should be allowed to go out tonight because I should be allowed to go out tonight. It's, your parents are going to be like, wow, that's outstanding argument. You should get me a new phone because you should get me a new phone. Oh yeah, I'm convinced. You won me over. We need to build off some other kinds of things. So vertical angles, we want to use the definition there. What's the definition of vertical angles have in it? What other old word?
Isn't it besides what
Opposite rays. So can somebody give me an example of some opposite rays we've got?
A ray, CA. and
CA is
CE.
opposite with
CE.
CE. Do you have another group like that?
Yeah.
Yeah, who?
Ray CB and CE.
That's all true. Those are opposite rays. That's the only thing that vertical angles could remind you of is opposite rays. That's our only connection. Opposite rays only has one connection. What's our only other word that connects to opposite rays from pretty deep in our memory?
Linear pair?
Linear pair. So we could use the definition of linear pair and say that certain angles form a linear pair. Can somebody give me, we'll use the numbers, it's fine, a pair of numbers there that is linear pair action.
1 and 4?
1 with 4. Let's do another pair.
2 and 3?
Did you say 2 and 4?
3.
3 and 4, that's fine. We'd like to get 1 involved. We'd like to get 3 involved. Those are the ones we're trying to prove. So ideally, get 1 and 3 involved in some of the name game here. And then try to make another connection. Linear pair only really connects to like 2 things, but one thing is probably more memorable.
Supplementary?
They're supplementary. So I'm going to just put ditto marks and say those same angles I just listed are supplementary. What is that? If 2 angles form a linear pair, then they're supplementary.
Supplement postulate.
That is the supplement postulate. Now supplementary has a few connections, but there's only one connection to supplementary that has to do with congruent. So keep in mind always a little bit on where you're going. What connection do we have that has supplementary in it and also has congruent in it? Either the sentence or the title.
Supplement theorem.
Supplement theorem. Supplement theorem is coming. What's the, not yet though, but that's what I'm fishing for. What's the supplement theorem say? Supplements,
Supplements of congruent angles.
that's correct. So we have some supplements. Why can't we use the supplement theorem yet? What don't we have that the supplement theorem requires of us? Congruent angles. Okay, supplements of congruent angles are congruent. Within this pair, which angle from this line is congruent to an angle from this line? Somebody out of these two is congruent to somebody out of those two. Which one of these two is congruent to which one of those two? Not yet, we don't have supporting like logic to say one matches anybody yet. Four matches four. I think we can support that. Angle 4 is a match for angle 4. Why is angle 4 a match for angle 4?
Reflexive.
Reflexive. Until you have congruent angles, you can't use the supplement theorem, okay? But if these are congruent, the supplement theorem now can get used. If these are congruent, then
1 and 3.
1 and 3 are congruent. So I ran out of board space, so there's number 6. Would be angle 1 congruent to angle 3. That was the supplement theorem. Was that easy? No. Was that hard? Yes. Can you do that on your own yet? No. Okay. Can we do that as a group and make some sense? Well, hopefully we'll grow. But start with a picture, start with a given, start with a prove, and then what you're trying to do is layer one thing after another. Each word should remind you of another word, and you gradually just try to build these connections up, and sooner or later we figure that out. That's probably a harder than average proof. So if you're looking at this thinking, is this supposed to be an easy one? No. Just isn't. In the homework, you were asked to prove theorem 4-4. That's easier than what we just did. You were asked to prove the complement theorem. Because you have the supplement theorem, that would be easier than what we did. The basic is picture, given, prove, columns, and then you try to layer one thing after another. Definitions are going to be pretty dominant. If you're doing a proof, I gave you at one point a paper that's titled at the top, words that might get used in proofs right now, something like that. So if you're doing a proof and you don't know what to use, look at that paper, because the only things we're going to use right now are from that paper. There's nothing off that paper that would need to be in a proof. Question about what we're trying to do? That's not as important to have for your files. I told you write down like proofs that you know are right, like have a folder of that somewhere. It's a good idea. That one's less important than the supplement theorem. The supplement theorem, you need to do the complement theorem. This you're not going to super need. There's also a proof in the book on 105 that's a different variation on what I had. And we talked about this the other day. Is everybody's proofs going to be the same? No. But any correct proof of this would have to have something about linear pair. It would have to have something about supplementary. It would have to have the supplement theorem. There wouldn't be another way to do that without those things. But there would be some wiggle room. Like we talked about, would everybody's picturing be the same? No, I mean, the pictures are going to be all different because people might spell their names and do whatever they do. 103, let's take a peek to 103 and do a little homework help over there. So 103, we got a request for 10. So request for 10, I'm going to start from the hint and work backward. So in number 10, they say hint, we're going to do some algebra, let ABG be X. So this ABG zone is going to be an X. And they say, let the DBE be a Y. And then I'll read backward a little bit. They said ABG is congruent to KBG. Not to be confused with Russian stuff. So if ABG matches KBG, what could I do in this KBG world?
Make an X.
Make another X, because they're supposed to match. They also tell us KBD matches DBE. So if KBD matches DBE, That's another y. So that gets us started. What they're asking us to find is GBD. So they want us to tell them what's that. And I'm just going to quit talking because that's pretty strong. Request came in also for 9. So 9, what they did for you is a partial proof. So they did all the statements. What you're trying to do is some reasons. So this is very similar to what you guys tried to do with the one homework. I did 7 for you. Then you did 8 and 9. And then we came back. I did 8 and 9 again for you, but I haven't posted the video for that and won't until the homework is like all resolved. But we're doing the same kind of thing here with this 104 thing. So 104, first reason generally is given. In number 9, read the paragraph. How many things are you given in number 9? Is there only one thing given, or is there more than one thing given in number 9?
2.
There's 2. So 2 of the reasons are going to be given. So you're going to have to just like skim through there and match up what's given from the paragraph with what's given for the reason eventually. There's going to be 2 of those. Then you're going to have to kind of just look from line to line and see how they're trying to progress from thing to thing. So from 1 to 2, if rays are perpendicular. Have we ever had that on the quiz? Perpendicular rays.
Yeah.
Yeah, what do perpendicular rays do? They're the sides of a right angle. So it isn't shocking if we read along that number 2 talks about
Right.
right angles. We just have to figure out, is that a definition, theorem, postulate, or property? What is the name of the fact that tells us perpendicular rays are the sides of a right angle? And try to fill that in, but I don't want to give away all these answers because it's still a live homework. But 2 would be the name of, what fact is it that perpendicular rays are the sides of a right angle? Then you think along again. What do right angles mean? Measure 90. So when we look at 3, it's not a big shocker that the measures are 90. We just have to come up with, what is that? The name of that fact that if we have right angles, they measure 90. Then here's a different tip for 4. For 4, it has, if you look at what's going on in 4, it has nothing to do with what they talked about in 3, 2, or 1. Number 4 is talking about ABG. They never talked about ABG. They're talking about GBE. They never talked about GBE. They're talking about some new stuff. So if they aren't looking at 3, 2, or 1's statements, where must they be looking? Picture. They're getting something from the picture. So there's only, if you look at the proof words paper, somewhere you have a words, proof words 347 paper, there's only 2 pictures that apply. What were the only 2 pictures we drew on that thing that day? We drew a linear pair. Is that sentence talking at all about linear pairs? Number 4 in the proof statements, are they talking about linear pairs? No, so it's not that. So what's our other picture?
The
Angle addition postulate. What's the angle addition postulate look like on your quiz? When I say angle addition postulate, what do you write me? Something that's like,
50 is in the interior angle ABC.
okay,
Then angle DBC
yeah, measure this angle
plus
plus
DBA
measure
is
some other angle
ABC.
equals measure of a third angle. Does your picture look kind of like this, just grown up?
Yeah.
Yeah. Does the statement in 4 look kind of like this?
Yeah.
Yeah. So that's what that is. That's the angle addition postulate. And then I'm kind of running out of time. But that's what we're doing as we work through 9. You're trying to kind of follow from 1 to 2 and figure out what is that. What is your most common reason type that you're gonna use?
Define.
Definitions. There are a ton of definitions down this thing. If you are gonna use a property, what property has been in every proof we've done so far until today? We didn't use it today, but what property, transitive is in like a super lot of these proofs. Transitive is in that number 9. If you're worried about losing your 103, I'd hold it for you. If you can improve your 103, keep your 103, keep your 106, keep working on those to make those better than they are. But if you want me to like hold it, keep it safe, that's fine.